Flour is the major ingredient for the bread, and combined with water, the flour is actually responsible for the structure of the bread. And since the formation of gluten is an essential component of the bread making process, and wheat is the contributor of the protein necessary for its formation, it is one of the most important ingredients that bakers need to control and monitor. Why? Again, because of the unique viscoelastic properties of the gluten in the wheat flour, and its gas retention capacity is extremely important. Water serves as both a plasticizer and also a solvent. So we must have water in the baking system. Without a water, we cannot have gluten formation, we cannot have dough formation, and also we cannot have fermentation. So both flour and water are extremely important, and they are critical part of the baking process. If you look at other essential ingredients, yeast is needed to convert fermentable carbohydrates into carbon dioxide and ethanol. So the major function of yeast is production of gas during the fermentation process. Because that gas results from this conversion provides the lift that produces a light, leavened loaf of bread. The secondary function of yeast also has some impact on the rheological properties of dough. Salt is generally used as levels of 1 to 2% based on the flour weight. And we will discuss the baker's math versus the true percentage in a couple minutes. But we add the flour at 1 to 2% based on the flour weight. And the major function of salt is masking the undesirable flavor. But then we know that salt has significant impact on the dough rheology. Why? Because of the shielding charges on the dough system. The dough is made stronger by addition of salt. How? Because of shielding charges on the dough system makes the dough and the gluten network stronger. Flour, water, yeast, and salt are the essential ingredients. And then we have non-essential ingredients. Where allowed by law, flour can come from milk might contain some non-essential ingredients. And when sugar is added, this is generally done at the bakery. And the main function of sugar is food for yeast that we need for fermentation process. And sugar is fermented by yeast, and at right level, it might provide some sweet taste to the bread. So in some countries, there is very high percentage of sugar as part of the baking formulation. And in some countries, it is added just a small amount so that it could be fully fermented by yeast during fermentation. And again, the major function of that is food for yeast. With the proper enzymes in dough, sufficient maltose is produced from damaged starch. As we remember from previous lectures, damaged starch has significant impact on the water absorption. And since the starch granules are damaged, they will be more exposed to enzymatic attack. With the addition of alpha amylase into baking formulations, we can generate maltose. Maltose are two glucose linked to each other. With the right amount of amylase addition, sufficient maltose is produced from damaged starch into flour. Those will be utilized as food for yeast, and then maybe we do not have to use higher amount of sugar if we are using enough amount of alpha amylase to provide the food for yeast from the damaged starch. However, under many conditions, added sugar is typically used in many baking formulations. As we talk about more other non-essential ingredients, alpha amylase is the enzyme most commonly used in the baking formulations to hydrolyze mostly damaged starch, so we can produce 2-glucose sugar called maltose, and the maltose is going to be used by yeast during fermentation process. Another group of enzymes are endoxylenases. As you remember, we talked about arabinoxylans, and then arabinoxylans are classified into two groups based on their solubility in water. Water extractable arabinoxylans, they will have positive impact on the loaf volumes. Why? Because they stabilize the gas cells. Water unextractable, water insoluble arabinose islands, they will be detrimental for loaf volumes. Why? Because they interfere and they damage the gas produced during fermentation process. So we can add some enzymes. They can convert water unextractable arabinose islands into the water extractable forms. And they also decrease the molecular weight. So these type of enzymes are enhancing the bread quality by their action on arabinose islands. They are converting arabinose islands into smaller molecules so that they have positive impact on the loaf volume. And there are also various emulsifiers. And emulsifiers are a wide range of compounds. We are going to talk about them more. So emulsifiers are used about 0.5 of the flour weight, and the mechanism of their action, basis of the dough strengthening effect is not completely understood. It has been suggested that emulsifiers form a liquid lamellar films between the gluten and the starch. Then they improve the film forming properties of gluten. And the emulsifiers in more general term is monoglycerides. Those are very common anti-staling agents. And there are multiple studies. They are forming complexes with starch. And we are going to talk about them more into the controlling the staling of bread, because they have unique interactions with starch molecules. So they actually prevent staling of bread. And in general, emulsifiers in the foods can perform a variety of functions. The most important involves the reduction of surface tension in oil-water interfaces, and interaction with starch and protein components, and modification of the crystallization of fats and oils. So the selection of proper type of emulsifier for a given food product is normally based on experience and experimental tests or by trial. So in baked goods, the application of surfactants, they have specific functions. And it's essential that correct choice of surfactant is used for targeted applications. And emulsifying and stabilization of water oil, such as if we have margarine in part of baking formulation, or butter or cake in oil water system, or so they have different types of applications and targeted uses in different types of food systems. And the synthetic and natural surfactants have been increasingly used to improve the quality of yeast raised or chemically leavened or even non-leavened baking systems. And in this product, emulsifying is often of a secondary importance, but starch complexing, protein strengthening, or aeration area of the primary importance for when we are selecting the right emulsifying agents or the surfactant. So these are some example emulsifying agents commonly used in the baking applications, because they have these long chains, and this is the part of the molecule that can actually penetrate inside the starch crystal. This is how they are forming the amylose lipid complexes. And if you talk more about the non-essential ingredients and oxidants in the bread making include ascorbic acid, potassium bromide, azotocarbamide, we will refer that as ADA from now on, and calcium peroxide. They are added at the mill sometimes, or sometimes we can add them in the bakery. And they are used at the levels of parts per million, so very small amounts. And they can improve dough strength and result in bread with better loaf volume and texture. And other group of ingredients are fat and shortening. We are always adding fat and shortening in the bakery. They have plasticizing effect on the dough. Increased level of shortening in dough requires a decrease in the level of water and vice versa, so that we can maintain equal dough consistency. Additional non-essential ingredients are surfactants. Most common one is monoacylglycerols or monoglycerides, and a common level of usage is 0.5% based on the flour weight. Another important chemical that is very commonly used, the major reason is to control the mold growth. Remember, in the United States, the most typical shelf life of baked pan bread is about 10 days at room temperature. So we need to control mold growth. The most commonly used additive to control mold growth is calcium propionate. This is a conceptualized graph comparing the firming rates of a controlled bread, which will be shown in A, and then the bread containing a shortening is B, and then another bread containing both shortening and monoacylglycerols is shown with C. Here on the y-axis we have the bread firmness. The higher the firmness means the texture is harder. In the x-axis we can see the days of storage. So in the day 1 they have closer hardness, firmness rate, but as we increase the storage days, when we come to day 5, the control bread with no fat, it has much higher firmness value compared to formulations involving shortening plus the monoacylglycerols. Formulation C, that has both shortening and monoacylglycerol, is the softest at day 5 compared to other two formulations. Shortening and emulsifying agents, the surfactants, they have significant impact on the softness of the crumb during storage.